Hi there! In most of the videos I made on the Arduino UNO, I have used a homemade prototyping system which puts together the Arduino itself, along with a small LCD screen and a breadboard, so I can easily build the prototypes without causing a mess on the workbench. Some of you emailed me asking for details about this device, and since I had to build another one like that for my lab, I thought that the better way to answer all those emails was to make a video about it, showing all the details of the construction. And this is that video. Enjoy! The original idea for this project was actually not mine. While browsing on the Thingiverse website for something else, I stumbled on the device built by the user chiuyiming, sorry for the pronunciation. A link is in the description below. I immediately liked the idea and built what he called an Arduino test platform. After using the device a few times, I realized that I needed to add the possibility to attach external device to it, like potentiometers and sensors, and so I decided to import the design on my CAD program and add something else to it. I basically decided to get rid of the handle on top of the device and put there instead another plate with holes where I could screw potentiometers and other devices to use along with the rest. Initially I just moved the handle on the side, but in this version I decided to get rid of it altogether, since I don't see any usefulness about it. So here are the various pieces of the device, which need to be assembled together. You can retrieve the original files from Thingiverse, or you can get the whole thing I put together from the other link to the eleneasy.com website that I also provided in the description below. First piece is the plate that holds the Arduino board and the LCD, not the holes on the two sides to connect multiple plates together, and the holes on the top to screw in place the two PCBs. The second plate is the one to hold the breadboard, which needs to be glued to it. This plate has two holes on the larger side to attach it with screws on the previous plate, and it has also holes on the two shorter sides for other eventual attachments. The third element is the handle, which I decided not to use. The STL file is there anyway, and if you like it, you can certainly find a use for it. The fourth element is the last plate, the one I designed, which has 5 holes on top to attach 5 devices, potentiometers or other stuff. You can even make your own plates to add some type of devices with a completely different attachment. It's just up to you. To print all the pieces together, I loaded them all on the slicer and created the G-code for the 3D printer. It took a few hours to print the whole thing on my old ANET A8, but it was worth it. And here are the 3 plates on my workbench. This is the one to hold the Arduino and the LCD. You can see the holes on the sides for attaching the other plates to this one, and the holes to attach the Arduino and the LCD PCBs. This other one is the plate for the breadboard, which features a simple flat surface to glue the breadboard to it. And this one is the plate I designed to add other components to the prototype. The assembly of the prototyping system is very straightforward. I started by putting together the PCB's plate and the breadboard plate. To hold them together, I used a couple of M3 screws and nuts. The holes on the side of the breadboard plate are a little smaller than the ones on the PCB's plate, and so I had to force the screws in with a screwdriver. I believe the smaller holes were made like that on purpose to make it possible to hold everything together while the nuts are not yet attached. Next I attached the other plate, the one with 5 holes. Same procedure, same type of screws and same type of nuts. Note how I put washers on each of the 4 nuts. They help in tightening the screws without having the nuts sink in the plastic walls. Once the plates were all put together and so the platform was fully assembled, I started mounting the components on it. First I unboxed the Arduino, I positioned it on the plate making sure the holes on the PCBs and on the plate were aligned, and then I used nylon screws to attach the 2 parts together. I chose nylon to prevent short-circuit problems, and these screws are also very easy on the surface of the PCB, of course. The holes on the plate, however, are very tight, since they have to be used without nuts, and since the nylon screws are very soft, I wasn't able to screw them in. To solve the problem, I used a metal screw of the same size of the nylon nuts to thread all the holes, so that the nylon screws could be inserted more easily. After threading the holes, it was much easier to use the nylon screws to attach the Arduino board. Before attaching the LCD to the plate, I needed to do first some assembly on the LCD itself. In fact, the one I bought was missing the connector to attach the wires from the breadboard and the Arduino, and so I had to take one and solder it to the board. These connectors are usually soldered to the bottom side, so they are not in the way in case we want to put the LCD on a panel. However, in my case, there is no panel, and so I decided to mount the connector on the front side of the LCD to make it easier to connect wires to it while making prototypes. So I put aside for a few minutes the test platform and concentrated my attention to the LCD. I held in place the connector using some Fantac putty, grabbed the PCB with my third hand, always useful, and soldered the connector pins one by one. Finally, I was ready to attach the LCD to the plate. For that, I used the 4 spacers of size M2, and since the holes were larger than the spacer screws, I used some glue to fix the spacers in place. And yeah, I put too much glue and had to clean up the mess I made. Anyway. After inserting the spacers in the holes, I waited a couple of hours to make sure the glue settled and cured. And then, after checking that the spacers were glued and strong enough, I positioned the LCD on top of them and fixed it in place with 4 M2 nylon screws. Since the screws were thin, I also used washers to prevent the heads of the screws to go through the holes of the LCD's PCB. Was now time to install the breadboard on the last plate. You should know that standard breadboards have already a sticky pad on the back, to be fixed on various surfaces, like in this case. All I had to do was to remove the protective layer from the pad, and then, paying attention to put it exactly in the center of the plate, fix the breadboard to the plate itself. But be very careful when you do that, because if you stick the breadboard in the wrong position, there is no way to reposition it without breaking it. In fact, underneath that sticky pad, there is the back of all the contacts of the breadboard. If, in the attempt of repositioning the breadboard, the pad detaches, all the connectors will be pulled out with it, and it will be practically impossible to put everything back together. Well, you can still try if it happens to you, of course. One last thing I wanted to do was to attach on the bottom 4 of those anti-skid buttons so that the test platform would not slide on the workbench while working on it. And here is the finished device with the Arduino mounted on the center left, the LCD on the center right, the breadboard on the bottom, and the plate with the holes on the top. Finally, here is a view of the backside, where you can clearly see the back of the PCBs of both the Arduino and the LCD. Before closing, I just wanted to remember you that the 3D print files of the first 2 plates can be retrieved on Thingiverse, thing number 2353567. You can also get the same files on my website eleneasy.com, along with a file for the extra plate with the holes. All links are in the description below. Thank you for watching this video and, as usual, happy experiments!